Let's begin. Today's August 4th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 5, 12, 14, 18, and 19. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. And on the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at our first digit, the triangle digit, and will let us know whether its value is an even digit or an odd digit. Criteria card B will look at our first and last digits, triangle and circle, and compare them. So should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card C will look at our 3 digits, triangle, square, and circle, and the Turing Machine will let us know which one is the absolute smallest. So should triangle be the smallest? Should square be the smallest? Or should circle be the smallest? Criteria card D again looks at our 3 digits, triangle, square, and circle, but this time it'll add them up and will let us know whether the sum of the 3 digits is an even quantity or an odd quantity. And finally, criteria card E will look at our first 2 digits, triangle and square, add them up, and compare that sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And remember, the objective of today's puzzle is to find that one unique 3-digit code that abides by all 5 criteria cards that we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I want to do is I want to test criteria card A. I want to know a little bit about that triangle digit. Okay, so the Turing Machine approves. Notice that I did choose an odd 3. The Turing Machine is just confirming that yes, the first digit in our solution must be odd. Not necessarily 3, but odd nonetheless. So let's go ahead and type that up in our notes in section A, that triangle is an odd digit. And since it is odd, that means we can cross out the evens, 2 and 4. The next thing I want to test is I want to test criteria card D, so that I know a little bit about, the overall sum of all the 3 digits in our solution. Okay, so in this case, the Turing Machine does not approve of what I have. Since we are adding them all up, let's add up 3 and 1. That gives us 4. 4 plus 4 is a total of 8. That's an even quantity, but the Turing Machine does not approve of it. So it's basically telling us that the overall sum shouldn't be odd. So let's type up that the sum is odd in section D. So triangle plus square plus circle should be an odd quantity. And let's see, if the overall sum is odd, notice that knowing that triangle is odd to begin with, if we want the overall sum to remain odd, then we have 2 situations. Either square and circle have to be both even or both odd. The reason that works is, well, if you add 3 odds, yeah, the overall sum is odd. In the other case where they're both even, well, since square and circle are both even, the sum of 2 evens remains even. But if you add an odd at the end, that means the overall sum is odd. So we're looking at something that can be either odd, even, or all 3 odds. Okay, so what else can we test? Well, we do have criteria card E that tells us something about the sum of the first two digits. And the only way that sum could be a 6 is if we add two odds. You can't mix it up with an odd and an even. We're also comparing the first and the last digits. So we do have a pretty good mixture or representation of triangle, square, and circle throughout our cards. Just trying to see if there's anything, any clue to tell us, whether we're dealing with two evens at the end or two odds. We do have this equal option in criteria card B, where triangle and circle could be the same thing. We could have a pair. But let's just go ahead and test criteria card E and see where that takes us. Okay, so notice that I do have a 3 and a 1 for triangle and square. That sum is less than 6, but the Turing machine does not approve of it. So either the sum is equal to 6 or greater than 6. So let's go ahead and type that up in our notes in section E. And that again is that triangle plus square is either equal to 6 or greater than 6. Well, I guess that's it. That does it for this round. We've already done our 3 Turing tests. And so now we're going into the phase where we'll be discussing how to construct a good second round proposal. So if it is going to be a sum equal to 6, the only two possibilities are 1 and 5 in some order, or 2 3s. And then for greater than 6, then it'd have to be at a minimum of 2. So let's see, the other thing that we didn't test is we didn't test how triangle and circle are ordered, nor which is the smallest. So let's see, since we do have an overall smallest, that's interesting. It can still be 1 for sure, because again, you could add 1 and 5. So the only way triangle and square, well, not the only way, but triangle and square are the ones that could potentially be a 1. Oh, so could circle. But so the only thing we can say is that you can't have a pair of 1s, because there's nothing smaller, or 1 is not smaller than itself, and there's nothing smaller than 1. So if we're going to have pairs, it's going to be either 2s, 3s, 4s, or 5s. And so what else? So again, we're thinking either square and circle are both even. So what would that mean? How would that help us solve? Could it be that I'm trying to somehow, these values have to kind of fit like a puzzle, and somehow these clues, although not obvious, can unlock that solution. I'm just trying to see what it could be. So if we're going to have, if it's possible that triangle and circle are equal to each other, then obviously we'd be dealing with an all odd solution, because triangle's already odd, and if they're equal, then so what could it be? It could be 313 or 515, and we already know that we already know that the smallest, could it be that square is the smallest and it would have to be a 1? I guess the question is, how would you, so, well, it couldn't be 3, 1, because that sum is already smaller than 6, and that can't be. So 515, that's exactly 6. But that just seems too, simple. Somehow these cards have to interact with each other. So if the sum, what if the sum were 6? And circle is not equal to triangle? I don't think that would work, because how would you distinguish between 511 and 513? Oh, remember, we do need, yeah, okay, maybe that'll work. We do need a smallest. So I think 513 would work, where triangle is bigger than circle, square is the smallest, and the sum is 6. And the only way that could happen, yeah, let's try that. Let's try 513. Okay, since the whole premise was, again, the sum of the first 2 digits, let's go ahead and retest criteria card E. Okay, so yes, the sum is equal to 6. So let me go ahead and cross out the or and the greater than. And what can we say? Well, if it is equal to 6, then that means that they are all odd, right? Because the only way you can get a 6 with an odd is with another odd. So then, yeah, we are dealing with an all odd solution. And so the question is it 1, 5 or 5, 1? Let's see. We are looking for the overall, and yeah, and so we know that either triangle or square has to be the smallest. Okay. Because it has to contain a 1. Well, let's see, is that possible? There is an overall smallest, and 1 has to be in the mix, because you can't have, say, 3, 3. And they can't all be the same, so it can't be like all 3s. So it can't be 3, 3. Well, I guess, oh, that would be interesting. It could be 3, 3, 1. It could be 3, 3, 1. Okay, so let's, is there 1? So if I test the smallest and it's not square, again, it could be that it's not even triangle and it's 3, 3, 1. So how would you figure out whether it's 3, 3, 3? Can we somehow figure out that it's not 3, 3? I guess you could test, criteria card B, and it would let us know. So let's go ahead and do that. Let's test criteria card B. Okay, so since we're comparing the first and last, triangle is larger than circle. So let's go ahead and type that up for B. And that is that again, triangle should be greater than circle. And since triangle is greater than circle, that means triangle cannot be a 1, because if triangle were 1, there's nothing smaller. So it can't be 1 for triangle. And circle, likewise, can't be a 5, because if 5 is the smaller of the two, there's nothing bigger for triangle to be. So, can't be 5. Okay. Anything else? And so let's go ahead and test. Okay, so if it is going to be a 5-1, square needs to be the smallest. And let's see if that's true. So let's test criteria card C. Okay, that is also true. So, so square is the smallest. So let's go type that up in our notes. Oops. Okay, so it is the smallest digit. So obviously it can't, well, let's see, could it be a 5? Yeah, obviously square can't be a 5, because then if it's the smallest, what would the others be, right? Okay. Could it be a 3? It can't, well, yeah, it can't be a 3, because then what would circle be? If it's supposed to be the absolute smallest, there's nothing else for circle to be. So yeah, so square has to be a 1. And if it is a sum of 6, that means triangle can't be 3. Triangle has to be 5. And because it is the smallest, circle can't be 1. So it must be, circle must be 3. So yeah, so I think, yeah, we got it in that proposal 513. So it looks like that is our solution. So let's type it up. And I think everything else, yeah, essentially, if we didn't confirm it, you know, we modified our answers to fit what the Turing machine told us. So yeah, let's go ahead and verify our solution of 513. Okay, yeah, fantastic. Now let's see, how do we do? So we did do 6 overall questions, one more than the number of criteria cards, which hopefully means that we at least tied it. So we did ADE first, and then we did the others in the second round plus another E. So let's go type that up. So, and I think I already forgot. Yeah, DE were incorrect. So D and E were incorrect. Second round we did the others, and we got B and C correct, and E as well. So let's see, how do we do? Yeah, as I suspected, we tied it with 6 questions. That was, you know, very likely, and that's how it happened. So good solve, good puzzle. Like I said, we had a good mixture of representation. We didn't have any of the other cards where, you know, are there any evens? Are there any ones or fours? None of that. Everything just focused on the actual digits themselves, which is pretty rare. So good puzzle overall. What are your thoughts? Add those to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And if you don't want to miss out on any future videos, make sure to hit subscribe to be notified. Well, until next time, have a great one.